In order to figure out the average normal and average shear stresses on the board that is subjected to a tensile force of 200 pound, and here we are looking for the average normal and average shear stress in the wood fiber, which are oriented along the plane A, which is making an angle of 20 degrees with respect to the axis of the board. Now, to calculate these stresses, let's go ahead and first write out all the variables. So, for our normal stress, the variable is sigma, whereas for the shear stress, it is given as tau. Now, since we are looking for these stresses at an angle 20 degrees with the axis of board, it is important because we have to identify the cross-sectional area. So we need to make a cut along the plane A and identify that cross-sectional area to be utilized in these formulas. So to start, first of all, we will try to figure out the forces. That is the normal force that will be responsible for the normal stress, and the shear force given by the variable v that will give us our shear stress. So to begin, let's develop the free body diagram by making a cut along the line A and list down all the dimensions here. Now, since in this case, the height of the board is 4 inches, that is listed, and we are making our wood fiber plane is along A, that is 20 degrees with respect to the horizontal x-axis, whereas the width of this board is given as 2 inches. Now, since we have made this inclined cut, the force that is acting along the surface or along the area, that is our shear force given by the variable v, whereas the force that is making 90 degrees with respect to the cross-sectional area, or that is normal to the surface, is our normal force given by the variable n. Now, since we have made that cut at a 20-degree incline with respect to the horizontal, so our shear force is also making a 20 degrees with respect to the horizontal x-axis, whereas the normal force, it is making a 20 degrees with respect to the vertical axis as shown on the free body diagram. Now, once we have listed down all the internal loads and the external 200 pound, we can go ahead and start applying our equilibrium equations to solve for these unknown normal force and shear force. So to start, let's do summation of forces along the vertical y-axis equals to 0. In this case, the shear force will make a component along the downward direction by taking the sine 20 function. That's why I have negative v sine 20, whereas my normal force is pointing in the upward direction. That's why we have positive n cos 20 degrees. Adding them together will give the sum equals to 0. Since we don't have any external load applying in the vertical y direction, so we have only these two components. Simplifying, we get a relationship between n and v. Next, we can go ahead and write summation of forces along the horizontal axis equals to 0. In this case, I have an external load of 200 pound going towards the left. That's why it is given as negative, whereas my shear force component of v cos 20 and the normal force component n sine 20 is going towards the right. So adding them all together and replacing the value of n from our first equation in this equation, we get our value of shear force as 187.96 pound. Now, once we have this value, we can plug it back in our initial equation and solve for the normal force that is coming as 68.4 pounds. Now, once we have identified both our normal and shear forces, next we have to identify that cross-sectional area at which our shear force and normal force are acting. So we are looking for area A. Now we already know one of the dimensions of that rectangular cross-sectional area that is inclined, that is 2 inches given by the width of the board. However, we still need that inclined surface length given as question mark here. So to do that, we can utilize our right angle triangle and apply our trigonometric relation that sine theta is equals to opposite over the hypotenuse, and we are looking for the hypotenuse in this case. Simplifying, we get the value of that hypotenuse equals to 11.69. Now, since we have both the dimensions to calculate the area, just multiply them together and we will get our cross-sectional area. That is coming as 23.39 inches square. Now, once we have the area and the forces, the final step is let's just plug it in the formula for the stresses. So the average stress value is equals to 68.4 divided by 23.39. That is coming as 2.92 psi, whereas for the shear stress average, it is equals to 187.96. That was the shear force. Divide that with the cross-sectional area of 23.39. Our final value is 8.03 psi.